Mechanical gap fillers, MGFs, shall be able to fill up the gap between platform and train door. The MGF shall be a self-sustainable modular design. The installation work at the platform edge would require specific booking of track positions on designated nights. The partly installed MGF system at platform shall be self-contained and shall cause any disruption or inconvenience to the normal railway operation. The MGF shall be able to operate independently even without the completion of the whole installation of the MGF. All materials shall comply with the relevant EN or BS standards. Electrical or electronic devices or enclosures of electrical shall have a degree of protection not less than IP65. The safety integrity level of the system shall be seal-free. The material of the system shall not be a cause of flame to spread and emit toxic gases in case of fire. The system shall always maintain a safety state in any circumstances, including startup and shutdown. The design life of the system and the major components shall be at least 20 years. The MGFs themselves shall be elegant and integrated with the platform structure. The MGF shall be fabricated with a suitable material which can minimize the weight of MGF. The mechanical gap filler can be folded high. The surface of the MGF shall be heavy-duty, wear-resistant, and finished with an anti-skipping pattern. The maximum gap to be filled by mechanical gap filler is approximately 300 millimeters. The filler plate shall support weight passenger on wheelchair as well as luggage carried by passenger. The operation of mechanical gap filler shall not cause any damaging contact with the train. The setting of the MGF shall be in line with the train doors at normal stopping position. The preliminary sequence of the actions are listed as follows. Train approaches platform. Train stops. MGFs raised if the stopping accuracy is within the set tolerance. After the MGFs are fully raised, a confirmation signal is sent back to the signaling system. Train doors open. Passengers boarding and alighting. Train doors close. After the train doors are fully closed, a confirmation signal is sent back to MGF system via signaling system. MGF's loading may give visual audible warning. Train departs. The status of the MGF shall be displayed in the MGF status trackside indicator. Train stopping accuracies in different modes of operation is plus minus 500 millimeters for both ATO, automatic train operation, and ATP, automatic train protection mode. The normal frequency for the operation of the mechanical gap filler shall be 1 cycle, operate and return per 2 minutes. The response time, which counts from receipt of valid command from the signaling system to MGFs, fully raising from its normal position to operational position, shall not be more than 1.5 seconds. The MGF shall return from fully operational position to its normal position within 1.5 seconds after receiving valid command from signaling system. The casing of the MGF unit shall prevent ingress of rainwater. Drain holes shall be provided to prevent the flooding within the unit in case of failure of sealing. Structural interface with the civil provisions shall be simple and allow quick installation during non-traffic hours. Installation method shall produce low noise level which complies with the relevant regulations. The MDF control unit shall be the controller of the individual MDF unit. Filler plate is a movable plate which fills up the platform gap. The outer edge of the filler plate shall be made of rubber fingers. The contractor shall standardize the size of filler plates for different MDF units. The MDF interface unit is the control cabinet in which the signaling system and the MDF interfaces are connected and at which control signals are transmitted to and from individual MDF unit and panel. The MIU may be located at platform and shall have a degree of protection of IP65. Individual status of MDF shall be displayed on the MSP. MDF local control panel will be provided a head wall and a tail wall. MDF status trackside indicator made up of LED array shall be provided at each end of each platform. MDF power supply equipment shall be fed from station power supply. MDF power supply equipment shall consist of power supply units of control power and drive power to MDF units. PSEs shall have the capability to maintain the supply of control power for 30 minutes and drive power of 3 operations in 30 minutes in case of failure of station supply. All supply voltages shall be DC and shall not exceed 110 VDC. The contractor shall supply and install cable containment for the MDF system. The monitoring system shall provide indications of the statuses of the MDF system. The statuses of monitoring points will be sent to or displayed at MIU, MLP, and MSP. A list of alarms and the statuses to be recorded and displayed in MIU and MSP shall be submitted for review. Detection of object of filler plate shall be provided to prevent the lowering of filler plate when object is sitting on the filler plate. Small objects such as ladies' high heels and the lightweight object shall be detected by the object detection system. Mechanism for emergency operations shall be available for staff to manually operate the MDF unit without access from trackside. No movement or deflection of any parts of the MDF to trackside is allowed under all different load conditions. The passenger load is 3 kN per square meters. The MDF including filler plate shall be designed to operate under this loading throughout the design life of the MDF. The filler plate shall be designed to withstand a load of 2.5 kN applied around the leading edge of the filler plate. Any part of the filler plate shall not deflect for more than 5 millimeters and shall not deform permanently if the load is increased to 3.5 kN. The filler plate shall maintain a fully operational position even a horizontal force of 1 kN applied from trackside during passenger boarding. Failure of one of the sensors shall prompt the maintenance alert. In the event of a train hitting the filler plate for whatever reasons, the filler plate shall either be reinstated into its normal position or detached from its supporting structure without damaging the train body and MGF. Any failure within the MGF shall be refracted or bypassed such that train service delay due to MGF failure shall not exceed 8 minutes. A good system design, maintenance procedures, and suitable spares holdings are necessary to ensure the availability requirements of the MGF system. All components of the MGF shall be capable of being maintained or completely replaced within 3 hours or less during non-traffic hours.